Venn diagrams and set operations. So you are going to learn all about the universal set, basic ideas about Venn diagrams, how Venn diagrams represent the relationship between two sets, the complement of a set, intersection, union, do operations with sets, and then determine sets involving operations from a Venn diagram, and understand the meaning of a and or, and then use this formula for the cardinal of the union of two sets. The universal set is a general set that contains all the elements under the discussion. So it's the box. So whatever is in the box is the whole set. So A is this circle, whatever's in this circle. The complement of A is A prime. So it's at A apostrophe. Okay, so I'm not sure if I have this written down anywhere else. So the complement's the opposite. Complement means the complete opposite. So if we're talking about movies I love, that would go in here. A prime would be movies I don't love. Okay, so let's look at the first diagram. So we have the universal set, says everything inside. So we have A, which is the square, the triangle, and then a complement would be the dollar sign, and the fun. That's the universal set. A is whatever's inside the circle A. C is a set of elements in U that are not in A. So this really means A prime. It's the complement. So it's the elements not in A. It's the opposite. Okay, let's go to the next one. We have disjoint. Right? So the opposite of disjoint would be joint sets. So disjoint sets have nothing in common. Proper subsets, that's what we covered in 2.2. It's where A, all of A is in B. So all elements of set A are elements of set B. A equals B, so if they are the same, then we have A is proper set of B and B is proper set of A. This means A equals B if they're proper sets of each other, proper subsets. Sets with common elements. So you remember back in elementary school, you have the two overlapping circles, and then whatever is inside here is what is in common. Determining sets from a Venn diagram. So U is a universal set, so it's everything inside the box. So A, B, C, D, E, and then F and G. B is everything in B, so D and E. Sets of elements in A, but not in B. So these are all the elements A, B, C, and D, but it says not in B. So it's not going to include D. So it is going to be just A, B, and C. Example 2, determining sets from a Venn diagram. So same thing, we are just doing 2 more problems with that. Sets of elements in U, so all of these elements that are not in B. So D and E are in B. So it's going to be everything else. A, B, C, and then F and G. E, the set of elements in both A and B. So that's that overlapping part. So it's just D. The complement of a set, that's what I was talking about on the first page. So the complement of a set is symbolized, as A prime. Is that apostrophe is a set of all elements of the universal set that are not in A. The idea can be expressed in set builder notation. So all elements X, such that X is an element of the universal set, and X is not an element of A. So that's A prime. This shaded region represents the complement of A or A prime. So let's look at the complement example. So we have U is everything, the numbers 1 through 9. If A is 1, 3, 4, and 7, then A prime is going to be everything else. So 1, 3, 4, 7, 1, 3, 4, 7. So then these other elements are the complement. So you can look at them in the roster method or with the Venn diagram. So it's 2, 5, 6, 8, 9. 6, 8. One more example. They've given us U and C. So use roster method to describe the complement of C. So what I'm going to do is I'm going to use these numbers and cross them out of U. So 1, 3, 5, 7, 9, 11, 13, 15, 17. So C prime is everything but C that's in the universal set. So whatever's left, 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, and 20. The intersection, it's where they intersect. So it's the upside down U. So intersect means it is in both set A and B. So this is said as A intersect B. And what that means is all elements in both sets. So whenever you think about your Venn diagram like this is A and this is B, this would be your intersect. A, so let's find the intersection of some sets. So find each of the following of the intersections. Let's see, what do they have in common? They don't have 7 in common. 8, yes. They don't have 6 in common. 9, no. 10, yes. 11, no. 12, no. So the only thing that is in both sets is 8 and 10. And then the next one, let's see, 1, no. 3, no. 5, 7, 9. So these are odds. And these are evens. Intersection is something that's in common. There's nothing in common between the two lists. We have the list of odds, 1 through 9, and the list of evens, 2 through 8. They have nothing in common, so it's no solution. We have the intersection of a set of odds with the empty set. Well, it would be an empty set. And the next one, this says find set complement of A intersect complement of B. So what we're going to have to do is we are first going to have to find complement of A. So right now we have 1, 2, 5, and 7. And so 3 and 4 and 6 are in the complement of A. I put those together early for the whole set. Complement of B is going to be 1, 2 is I'm including that, 3 is I'm including that, 4, 5, 6, 7. So whenever we do the intersection of those two, we're going to find in common. 3 is in common and 6 is in common. Nothing else is in common. Okay. The next type of definition is union of sets, union means together. So you're going to include them together. The union of sets A and B is written as A, U, union B. So see how this is a U for union. The other one was upside down U, which was intersection. So the union is a set of elements that are members of both set A or set B or both. Definition can be expressed in subfield notation. X such that X is the element of A or X is the element of B. So you're going to put all of the elements of A and B together. So the union of this, we're going to list them all out. So I'm going to go to least to greatest. So 6, 7, 8. We're not going to list them twice, just one time. 9, 10, 11, and 12. So all of them together. Next one, same thing. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Union of elements and the empty set is all the elements. So it's no longer an empty set. Example of union. So A union C prime. So what we're going to have to do is find what C prime is, the complement of C. So 15, but we don't have 1. We have 15. We have 6, 14, 11, 13. So 4 and 22. So we want to do the union of A and C prime. So it's going to be all of them, which are the exact same set. Okay, the empty set and intersection and union. So if you want to union a set and the empty set, you're going to get an empty set. But if you take a set A and union it with an empty set, you're going to get A. This is with intersection, that means they have to be in common. This one says all together, so you're just going to do A. Performing set operations. So this is going to involve more than one set operation. Always begin by performing any operations inside the parentheses. Here is an example. We have, let's find out what A is. So A is everything inside the circle. So 3, 5, 9, and 12. B is 9, 12, 14, 17, 19. The union of them is everything together. 3, 5, 9, 12, 14, 17, 19. U is the universal set, so it's everything. 3, 5, 9, 12, 14, 17, 19. And then we have to include the ones outside the circle, 22 and 26. The word or refers to union. A union B means it's in A or B or both. And refers to intersections. A intersects B. So in A and B. Okay, the formula for the cardinal number of a union of two finite sets. So the cardinality is all the elements. You want to find out how many are in A, how many are B, and then subtract how many are in A and B. Because then if you don't subtract that, then it's going to be double counting some of those numbers. So let's look at one example. So set A contains 17. Let me write cardinality of A is 17. Cardinality of B is 25. And then 13 elements in common, set A and B. So the union, we're going to use this formula here. In A union B, found by doing cardinality A with cardinality of B, then subtract cardinality of A intersection. So using that formula, it's going to help us. Looks like even. So this would be 17 plus 25, subtract 13, because 13 is what's in common. Add these together, 32 minus 13, 29. So there's 29. Okay. Cardinal number of two finite sets. It says, indicates that 190 are willing to donate blood, 340 are willing to serve free breakfast to blood donors, 120 are willing to do both. How many students were willing to donate blood or serve? So let's say donate is 490. Let's say serve is 340. And then they're willing to do both is 120. We're going to do this the same way. We're going to add these together and then subtract the both because we don't want to double count. So do 490 plus 340 minus 120. So that will be, what is it, 710? You would add these and then take away the both. See someone on the last question. Let x be all the natural numbers between that are less than 9. So the universal set is going to be 1, 2, 3, 4, 5, 6, 7, and 8. And then set A is all natural numbers, all odd natural numbers. So 1, 3, 5, and 7. Set B is going to be all even numbers. 1, 6, 8. And then C, we have a third set here, is all the numbers between 1 and 6. So 2, 3, 1, 5. Okay, so we want to find A union U. A union U is just U, the universal set. I do want to go ahead and make this. And then this. So this would be U, this would be A, B, and C. So let's put our numbers in here. So A is 1, 3, 5, and 7. 3 and 5 are also in C. In common with C. So I just put 1 and 7 here. And then B, we have 2 and 4 that is in common with C. also has 6 and 8. So let's see if we have included everything. 1, 2, 3, 4, 5, 6, 7, 8. So everything's included. All right, so let's do a couple of other questions. So A intersect B. Do A and B have anything in common? Anything there? Nope. So it's an empty set. A union C. A union, or intersect, sorry. That is 3 and 5. Let's do B intersect C. That would be what they have in common, which is the 2 and 4. Let's do C union B. Would be everything with C and B. So that would include 2, 3, 4, 5. All those 2, 3, 4, 5. And then also 6 and 8. Okay. Hopefully this helps you on your assignment.